Addition is what we do when we want to find out quantities of things, in particular when we're adding quantities to each other. So if we have two numbers, this is really easy. 2 plus 3, they can use their hands to see it, they can use manipulatives to see it. This is something they're learning in kindergarten anyway, so they're going to be using things that they can see with their hands and actually conceptualizing the math on that. They can see that 2 plus 3 is 5. Okay? When you get a little bit harder, let's say you've got 22 plus 33. Now we've already learned place value. We've got ones here and we've got tens here. These aren't just arbitrary numbers that are in a row. That's the way that we're taught how to teach it. In fact, traditionally, they'd even put a line down here and they'd say just add the columns. 2 plus 3 is 5, 2 plus 3 is 5, the answer is 55. But why? You have no idea. In your mind, you're not thinking about the number 22 or the number 33 or the number 55. You're just thinking about 2 and 3 and 5. You're not actually understanding what's going on. So to bridge the gap between doing this problem this way and the word problem that would be associated with it, you'd have to do all sorts of crazy thinking that children sometimes have a difficult time doing. So if we do this problem another way, they'll actually be able to see what the numbers are doing. We've got 22 apples. Mom comes home from the grocery store and she's got 33 more apples. How many apples do we have? We don't have 2 plus 3 is 5, 2 plus 3 is 5 apples. We have 22 plus 33 apples. In the ones place, we've got 3 and 2. That gives us 5. In this column, in the tens column, we've got 2 and 3, but it's not really 2 and 3. This 2, because it's in the tens column, represents 20. And the 3, because it's in the tens column, represents 30. 20 plus 30 is 50. We actually have 55 apples. Now, not only did we get the same answer, but we know why we got that answer and what it means. 50 is a whole lot of apples. That's a big number to understand, and you can't understand it very well when you're breaking these up into their individual numerals. Let's take a problem that's a little bit harder. Something where we have to carry. So let's say 48. That is a weird looking 4, but let's go with it. 48 and 33. Okay. Now traditionally I would go 8 plus 3 is 11, put the 1 here, carry this one. 1 plus 4 plus 3 is 8, 81. Awesome. Fast, got the answer I wanted. But I still don't understand what's going on. I'm not actually answering a problem. I'm just playing with numbers. And for some kids, this is really hard. So let's do this another way. 8 plus 3 is 11. I'm going to write 11. 4 plus 3 is 7. But this isn't actually 4 and 3. This is 40 and 30. 40 and 30 is 70. Took me a little bit longer, I know, but the benefit to doing it this way is that I can do this in my head when I get older. As I get better at math and as I'm learning more things, this will become very automatic. 11 plus 70, easy to add in the head. 48 plus 33, unless I've got a really good visual working memory and can see what I'm doing with my carrying, I'm going to try to run for my calculator. But this is really easy. 8 plus 3 is 11, 40 plus 30 is 70, 11 plus 70 is 81. I can do that in my head, and it'll become very automatic as I get older. So while it may take more time to learn now, it'll ultimately save a lot of time in the future. And more than that, it helps them actually see what the numbers are doing and what the quantities look like, because it's actually describing a real event. We don't want them to be forever stuck thinking that math is just numbers on a page. Math describes real things, and it's important for them to see how that works.